Hello and welcome. My name is Ted Stewart, and today's webinar is going to be on the optimal path for SIL certification for manufacturers. My name is Ted Stewart. I am the Program Development and Compliance Manager here with exida. I have a little over 10 years of experience in safety and high availability automation systems, manufacturing, lean process improvement. My background, I started my career with Lockheed Martin in missiles and fire control in Orlando, Florida. I then transitioned over to Harris Corporation, working for wireless products groups where we made a lot of little black boxes that could locate and track people. So that was a lot of fun. And then I moved over to exida. People think I'm crazy because I moved from Florida to Pennsylvania to the corporate office. However, it's probably been the best move I've ever made career-wise. I absolutely love it. I've been with exida for a little over 5 years now. I help manage the OEM certification division. I'm the deputy quality manager and the director of the CFC program. So I get to wear a lot of different hats. So every day is a new experience. If you don't know much about exida, we are a global company that started around 1999. Dr. William Goebel and Mr. Rainer Faller, they started the corporate office, one in Germany and one here in the United States out of the Philadelphia area. We now help with functional safety, alarm management, and cybersecurity. Which cybersecurity is just ramping up so quickly. But just with that being said, exida, we're involved with the whole supply chain of functional safety in many of the different industry sectors. Anything from the original equipment of the manufacturers who require this product certification, even to the end user side that will use those products. We have software tools, training, consulting, and templates related to functional safety, security, and reliability. Now, you can see here we do have main products and services. We kind of categorize them into 6 different areas, whether it's consulting for the different standards, whether it's engineering tools to help you perform the work. If you're looking for a certification, like which will be on today's topic, we have trainings all over the world. I think we actually have 2 trainings going on this week even for different companies. So every week we do have a different type of training that we offer throughout the world, whether it's public or non, because some companies just pay us to just go directly to them. We have reference materials where I believe we have 1 or 2 new books coming out even this year. And then we have the personnel certification program, which is your CFSC, CFSP, and now cybersecurity, which is CACE and CACS. So let's go ahead. I always do some intro slides before we get rolling. And if you guys don't mind, there is a question toolbar that's located there. Feel free to ask questions. If I'm able to fit it into the presentation as I'm going through and I see your question in time, I'll answer it live during the presentation. If not, I'll have to wait to the end. And of course, if you do have questions that are more specific to you or a company specific question, I probably will not answer that in this live webinar, but I will answer you via email. So as long as you entered your email when you signed up, I'll be able to reach back and get a hold of you. Okay, thanks again. In today's webinar, we are going to be discussing the different paths to certification. But of course, in order to talk about certification and different paths, we need to make sure people know what functional safety is, why people are getting certification, and then walk through those different options to see which one is right for you. So in general, functional safety is the adoption of 2 main industry standards. You have IEC 61508 and you have IEC 61511, right? Yeah, there's other standards, but let's talk about just the top level generic standards. So these standards, they help address the safety life cycle and the different types of failures from the faults. So this functional safety, it'll dive into a company's core quality management system, and it helps determine the architecture constraints and also that product or that system's failure rates. So the goal of functional safety is you want the automatic safety function to perform its intended function correctly, or the goal could be the system needs to fail in a predictable and in a safe manner. And that's key is, because it's not if, but it's when something does fail. And when it does fail, we want to make sure that it fails in a safe way and it reduces the risk to people when it does happen. And you want to mitigate that as much as possible. So functional safety it has become a greater awareness in the last decade or two. However, you still see those companies being reactive instead of proactive. And when an accident occurs, even with a reputable company site, it could be oil and gas, could be an automotive, any industry, they start rethinking about functional safety, right? They become, oh, I'm reactive. I better do something with functional safety. That could happen to me, and it's a normal human reaction, which unfortunately it wanes over time until something else happens, and then all of a sudden they think about it again. And there is a debate that only if the accident could have happened at a sparsely populated or desolated place, then the loss of human life, it could have been prevented. But, the hazards following Murphy laws, they have a tendency to kind of crop up at, the wrong place at every inappropriate time. And as human beings, it's true that, we can't outwit each and every possibility, which can cause harm. But learning from mistakes, not only our mistakes or personal mistakes, but you can also learn from those committed by others. And you can collect this information, you can brainstorm and determine the root cause that can make us less prone to fatal accidents and achieving a safer workplace, a safer environment, and a safer life. And that's ultimately the goal. And that's why functional safety keeps changing. That's why these standards keep changing. So why don't people have functional safety everywhere? Well, first thing is, people say, you know what? I don't have the time. Or, man, I know this is so good, but hey, we're just about to get into Q2 now, and I don't really have the budget. But maybe in a few months when we figure out, because, 2018 just started. However, I can't believe it's already March, and, we will get funding one day. Or, you don't have that personnel to complete this work. And this is where we're going to start talking about those certification options. Because depending on your time, depending on your budget, or depending on who you have working in your company, there's different routes that you can choose to make everything possible. So companies are now making the decision, what tolerable risk are they willing to take, and when are they really to dive in to do this type of work? And that's what we're going to talk about as soon as we learn, why people are actually doing this certification thing. And so what does that certification entail? Well, certification is a third-party authentication that's done against a set of requirements. We call this a scheme, right? And it's based primarily on these international standards. You can get systems, products, components, and personnel. You can get all of these things certified. And when you talk about functional safety certification, this does involve that detailed analysis of both your engineering process and also those design margins that result in those random failure rates and all of the different failure modes. And of course, that fourth bullet there, when applicable, cybersecurity certification involves a detailed analysis of course, your engineering process, but then your cyber defense mechanisms and that network robustness. So let me just quickly say that IEC 61508 is what the majority of people getting a product certified is going to get certified to. It's not a small standard. And when we certify a product, we verify that that product hardware and that product software design, the safety manual, as well as the processes that are being used for, like development, testing, configuration management, quality control, etc., they all comply with over 250 requirements of this not so small standard, IEC 61508. The review of that product hardware and software design, it includes the calculation of the product reliability data, which is needed for that design of the safer system, or the safety system, I should say. Also, a detailed failure mode effect diagnostic analysis, which is short-term FMEDA. This is also constructed to determine the hardware failure rates, its failure modes, as well as the diagnostic coverage. And as part of the certification, also that's analyzed is the number and type of product failures or field failures and the accumulation of operating hours. And these are important because then you compare that calculated failure rate number in the FMEDA to these failures here, and you make sure that they're comparable, because this is what demonstrates the product development and quality process is actually effective. So when this product does get certified, there's three areas that can now be considered complete, that end users that's looking at your product doesn't need to jump over. You have the systematic capability rating, which is, it measures how well that product is developed, or how well that product has in development processes that can prevent systematic failures. So this is your quality management system. You have the architecture constraints for the detector, which measure that product strength against the random failures. And then you have failure rates for that PFD average calculation that end users need when they want to perform their risk assessment. And I can quickly touch on each one of these and then we'll move on. But really, your systematic capability, it's established by obtaining a quality management system. It's audited per IEC 61508. Now, this QMS, it must meet the requirements of 61508 to reach whatever SIL rating that you need. If it's SIL 1, SIL 2, or SIL 3, those objectives change. The higher the SIL rating achieved, the more effective that manufacturer's quality management system. Okay, and so if you don't have this product certification, this barrier becomes hard for that end user. They're going to have to go through a proven and use justification. It takes time, it takes money, and things that are going to be asked when you're going through something like this are, how do you source your part suppliers, or how do you make modifications, or how do you have returns and recalls? How are they handled? And then when you go into architecture constraints, this is either by the complexity of that device, or it's by operating history. Either 1H or 2H is how the standards write them out. And there are different tables in IEC 61508 and IEC 61511 to help determine the architecture constraints depending on what SIL rating that end user wants to use for their SIF, what they're trying to achieve. And so when a manufacturer has a product that is certified, this certificate will let the end users know how to calculate the architecture constraints using those tables. It also, when you get a product certified, it will then inform the user, even with the hardware fault tolerance, the redundancy. Do they need multiple devices when they want to develop their SIF? And then finally, the failure rates for that PFD average calculation. The PFD average calculation, this is an equation that's given in the standard that basically uses 9 different variables to achieve that probability of failure on demand. It's based on dangerous failure rates. It's based on systematic diagnostic, proof test coverage, test intervals, maintenance, and other conditions that are basically controlled by the product and how that end user uses this device or this element. When you have a product certified, that end user now has the ability to take those failure rates that are now generated, and they can now, with the knowledge that they have and the variables that they control, right? They determine their own proof. They determine these different types of intervals. They then use those numbers with the failure rates to achieve their own PFD average calculation. This is not something for a manufacturer to worry about. Our PFD average is strictly for that end user to calculate for their own specific system. So I hope that made sense. So now there are benefits to product certification, and then we'll dive into the different options here. But when you use a certified device, it does make it much easier to design and implement a safer system in that process applications. When, of course, they're trying to comply to 61511 and even ISA 84, which are the functional safety standards. It can help reduce costs significantly over the long term, and it provides a measure of quality and reliability. Those that have a non-certified device and they use them in the safety system, they're going to have to worry about creating a rigor process for tracking and documenting that performance of all similar installed devices. This recording of operating hours and analysis of all these design repairs and failures must be done to justify that the device has the necessary reliability to be used in the application. And of course, common terminology in this field is they call that prior use justification. And so that's why many people use an independent assessment to help them to improve the quality and reliability of these certified products to ensure that they do meet that standard. So the IEC 61511 standard and its US equivalent ISA 84, this is what defines those requirements which must be followed by that end user in those engineering firms when they design and implement that safety system. So it's recognized as good engineering practices by insurance company and regulators like well, for here in the United States, it's OSHA. It's also in many parts of the world, like Europe, where it becomes law. And using certified devices just makes it easier to comply with those standards. It helps reduce your liability in event of an accident. It also helps you get a cost-effective, reduced risk to a tolerable level, ensuring, of course, that you're not over designing, you're not under designing, and you can save where you need to in costs. And finally, when you do have a product certified, of course, it becomes public knowledge, and users can now they go to a website called SIL. They can shop around. They can figure out what products are already certified, what they can use in their system, and this allows them to review the assessments for different products to determine whether that device is a good fit in their particular application. Okay, so here we go. Fun stuff. Now everyone is familiar, at least at a top level, with what functional safety is, what the value of certification is, and now let's figure out how you're going to achieve certification. What you see in front of you is kind of a typical flow chart. I try to clean it up so that there's not too many boxes on your screen, but when you look, there's a key. So yellow is basically a decision needs to be made. Red, we'll call it customer, or we can call it optional. Not optional, but optional in the sense that either the manufacturer or exida can do. And then the black box is what the certification body will do. And the standard practice is you start your project, you start a gap analysis, you perform it. If there's you have to create your process documents from that gap analysis. As long as you're good and you don't have any gaps, you move on to the design, your architecture constraints, where you then, if you don't pass everything there, you need to update those procedures again. After that point, you create an FMEA or a HAZOP for that design. You then move on to an FMEDA, where you calculate your own failure rates for that product. You then move into a safety case, where when I spoke about those 250 different requirements, you need to have some kind of system that shows how you meet each and every requirement of the standard. And of course, when you pass all of those, you then get issued the certificate. So if you had a 30-second spiel of what certification process looks like, this would be it. So let's go into a little more detail of the key certification tasks, because there's 4 of them. You do have the manufacturer's procedures, which, and I'm just going to read these boxes here, but the manufacturer, they have to have significant detailed design and test procedures. So these documents, they must be included for all steps required by the standards, along with all the documents needed to start each task and documents to be produced in each step. So whoever creates these procedures, they need to know the standard very well, and they need to understand the optimal process to be used, because this can be very tedious, can be very cumbersome. But that's the first key milestone when you're going through certification. Then the next one is when you want to analyze that design. And that's when we move into the FMEA or the HAZOP. This is a systematic design review process. It's done at a very high level of design. Usually people use the block diagrams. And this is where it detects those design faults and identify those design improvements. So those performing this task, they should be experienced in this method and all of the benefits that it comes with it. And without this, the task can take an excessive amount of time, and sometimes it has very little benefit if it's not done correctly. Okay, let's go to the next milestone for certification. That's the FMEDA. This is where you analyze those failure rates, you analyze those failure modes. And this is the method that will predict those failure rates and failure modes of the product. So this information, it's needed by those end users, those customers, to do system level design and expert component failure rate knowledge, and a component failure mode database is derived from this failure rate data, and is this something that needs to be required? And of course, your safety case, like we spoke before, the safety case is a document where it's going to list all of those different types of requirements for that standard, along with arguments. So you say, okay, here's the document that I say, this is how I meet that requirement. But then you also need a separate argument to justify how you meet that, whether you pinpoint, hey, in section 3.5.3 of this document, this is where it states this, and this is how I mean this meets this requirement. You go through the 250 plus different requirements, and you develop this, we call it a safety case, and that's what we would do, and that's the interpretation to help justify to that certifying body, if you're doing the work of the manufacturer, or for the certifying body to do that for the manufacturer, so that when if there's an audit that ever occurs on either the manufacturer or even that certifying body, now there's that evidence, that proof that shows, yes, you do in fact meet those requirements. Okay, so for us, our typical certification process, and you'll see some of those red boxes are now black boxes, and it might not be easy to see, but even all the red boxes have a black box around it as well, saying that it's a team effort in a sense. But in the top right, you'll see that when you perform that gap analysis, exida will work with the customer to help correct those gaps. So we do provide workshops with templates to detail the speed of this gap requirements and anything that you have. If you look to the left side now, I'm going to track down, I don't know if you can see my mouse, maybe you can. Over here, exida corrects the gaps with the customer, and this is when you get to your architecture review. So exida can provide workshops with process templates, which will help detail and speed up these gaps as well. You'll then what will happen is exida will perform with the client an FME or a HAZOP, where we'll come on site, we'll look at the design, we'll find the risks. We can then perform the FMEDA analysis. We then create the safety case for all of the different requirements, as you saw. And then if there are any outstanding gaps with the standard, whether it's at the beginning of your design or with the artifacts section, then right here we'll be able to provide any kind of templates or reading material to help you fill in those gaps as well. Once everything's completed, you pass and you get your certificate, and that's standard with exida. So when you come to exida and you say, hey, look, I just need you to do it for me, how, or what do you recommend? This is the process that we recommend. Okay, however, with that being said, there's even paths before you even decide who does what work. All right, there's 3 optional paths that you can go through, and you'll see in the standard, if you haven't already, when you look at it, there's things called 1S, 2S, 3S. You'll even have 2H. But let's talk about these 3, because these 3 demonstrate the systematic capability for complex software-based systems or even hardware-based systems. So you can have even type A or type B products that go through this, which type A, or let's just say your, for lack of better words, your dumb devices, ones that can't think for themselves. And then type B, of course, is those with like microprocessors, with all the software. But what we've done is we've interpreted that all these words, right, 1A, 1S, 2S, 3S, they basically come down into 3 distinct ways to get certified. You can design and test a fully compliant system or product, or you could go through the whole thing and with proven in use and do with changes, or you can do everything and allow no changes in that process. And let's talk about each one of these options. So the first one is option 1. This is where you have a new product, it's in development, it's coming out, or maybe it is out. You haven't gone through SIL certification before. It's a new design. Full hardware failure analysis needs to be done. The design must follow the design process requirements, right? And for each one of these, the reason we do A is because of the random failure integrity. The reason we do B is for that product systematic failure integrity. And of course, you need a safety manual to explain how to use that product at a system level. And that's what gives you the integrity, once again, for that systematic failures. When you look at what's required, so I showed you the process. Now this is more detail. These are some of the items that when you have a new product, you must now have. For example, you're going to be looking at your process documentation. If you look at the far right side here, you're going to need a functional safety management plan. You need a safety requirement specification. You need validation test plans. You'll need shipping records, failure records, tool justification, software process, coding standards. The list goes on. This is just abbreviated things of the process documentation you should look at. And then what we'll be doing is we'll look at and generate a gap analysis report to help you figure out if there's any gaps here. will generate the FMEA report, FMEDA report. There's detailed FMEDAs if you choose. There's fault injection lists that we can generate. There's software HAZOP reports. There's communication safety reports. So these are the different reports. But so when you do a new process, of course, there's no quote unquote shortcuts to get around any requirements in the standard. You basically have to do everything, and that's okay. It just it's just a longer process, which is fine. Now, if you do have a product and say it's already been out in the field, and you already have well-documented field history of this product, now you still do have to have that full hardware failure analysis. And then now you can provide that field data collection process. We will come in, we'll audit that process, we'll see if there's quality data available, we'll analyze it, we'll see if there's any lack of design problems, right? This stuff starts getting filtered out because you can prove that, hey, it works. I can show that, hey, this is a proven and used product. And of course, you need that safety manual to explain how to use it. But when you look at the process here, that same chart I just showed for option 1, you can now see, hey, wow, look, I can start eliminating some of these requirements when I go and get certification. So now I can say, hey, look, yeah, I want to get this product certified, but hey, it's been out there in a while, so I don't need to go through all the requirements. Now I can say, hey, it's proven in use. I have this field failure information. So look, your FSM plan kind of gets knocked out. You really don't need to do a gap analysis anymore. You can get rid of your tool justification, the software module test plan, the software integration test plan. A lot of these things start moving out because while you have those shipping records and you have that failure records to provide the, hey, this design does work. Look at my results. Then you move into option 3. And option 3 is this product it's well documented. It has that field history. However, sometimes people say, well, look, I've had this product. It's been out here for 30 years. Realize that, hey, I'm not going to make any changes to this product. Okay. Or, hey, it's going to probably be obsolete in a year or two. I really don't care to have changes. Can I do a route where I can avoid all these other modification documents, or maybe I don't have an impact analysis, or I don't have a good way of tracking a change? Well, look, if you go option 3, you don't need to worry about that. This is now saying you still need to have that full hardware failure analysis, right? That FMEDA will still be provided. I don't have any additional bullets here, but you'll also see that, hey, look, we do have a quality management system. However, the biggest thing here is we don't have to worry about changes. And when you don't have to worry about changes, now you have a lot of red boxes here that say, hey, look, don't worry about this. Don't worry about tool justification. Don't worry about coding standards. Don't worry about your software process. And now certification becomes even simpler. I don't want to call it easier because you're still going through a decent amount of work, but you can now avoid a lot of the different requirements in the standard. And some people like this. If you ever came to me, I would always tell you, this is a good route if you have that product going obsolete. However, knowing most of our customers are ambitious, they have these products that are always changing. The biggest thing here, and I think I didn't even touch on it, is if you say no changes, that's fine. We'll get you through certification really fast. However, if a change needs to be done, right here, a full safety audit must be performed. Okay, so keep that in mind, because even other certifying bodies, they'll directly put you to option 3 because they can get you through the quickest, it's the cheapest. However, when you make a change, you now have to go back to that certifying body to get the whole process reevaluating, which takes more time. It takes the manufacturer more money, but it's an option if you have a product that's not going to make changes. If you have a product that probably make changes, I personally wouldn't go this route, even though you save a buck or two. However, that's not for me to decide. So just real quick, you have on here, this is, I threw these in, there's 2 of them. I kind of wanted to share just different experiences that people have had, but when people use different agencies or they don't understand the full story, you can see here that this proposal, or this quote here, it said, look, we got a proposal from, and without saying any certifying body's name, right? And the price looked good. But our engineers, with the process that they presented, most likely it was where the manufacturer did most of the work. It said between 1,000 and 2,000 man hours were needed to do that FMEA, that HAZOP, that FMEDA, and that safety case. And after discussing this process with exida, they estimated, hey, exida's process, it would probably be only 200 man hours for us to achieve certification. So that's just showing you, hey, look, there's different ways of doing certification, whether the manufacturer takes the responsibility or you have a certifying body take the responsibility. Another thing we got back from a guy out in Texas is they said that they've been using exida. However, they have a sister company in Texas that uses a different certifying body. And he said that this is what he said. He said, I describe our experience with exida. Then I asked the engineering manager at the sister company about their certifying body, and he said it was much harder to get a certificate from XYZ. I interpreted that mean XYZ is a tougher technically, but when they really looked into why it was harder to get certification, it looked like it was, it says he reported that XYZ did not respond to their emails. They put them on the back in the wait of the queue every time one document didn't pass. And then they had to do the task over and over again, a lot of iterations, it sounds like. And it took them months before they got the final certificate, even after they passed. So, I mean, there's different experiences. There's different ways of going about things. And that's why I go into this. And this is something that we don't talk about enough, I don't feel. And it's really option 4, because as functional safety becomes more known and we have more CFSE or more experts out there, you know, if manufacturers have strong functional safety expertise and they have the available engineering man hours, look, manufacturers can do the work themselves. And that's what those red boxes are there. Basically, it's saying, look, if you want to do this work, if you want to create these procedures, you want to do your own HAZOPs, your own FMEDAs, your own safety cases, that's fine. It's actually not uncommon. We have many customers that do this work. And many of them, you know, maybe they might buy the functional safety book you see there in the corner to help them, because it's basically a guide. It has templates in there to get them through the process. But look, if cost is a factor, you have the man hours, option 4 might be your best bet, right? Because then your certification drops drastically down. All exida would have to do is, you know, we'll do that initial gap analysis. We'll give you the results. Go ahead, you clean them all up. You come back to us. We'll look at them. If there's things that you didn't clean up, you have to go back. You fix them again. You go through the iteration process. Then we'll look at your design. We'll have you do the design. We'll look at it. If it passes, great, we move on. If it doesn't, you know, you iterate again, and then you go off, you do the work, you come back when you're ready for the safety case review and you have all those requirements met. We'll take a look at it. If there's gaps, you go back, you correct all your gaps, you come back to us, we'll review it again. If it passes, great, you get certification. And that's a lot less work for us. And that proposal obviously is far less as well. So that's the thing. You can do the conventional way, you can do an exida way. You got 3 or 4 different options on certification. And the reason why I share this is because more and more people are going into SIL. They're looking for functional safety certification. But however, a lot of people like to do work themselves, and that's fine. We get that because guess what? There's a lot of great technical experts out there now, where 15 years ago, I mean, it was pretty slim pickings. So these paths are all available. If this is something you're looking for, please reach out. And yeah, if you have any even specific questions for yourself, you can email me, ask me any questions. But this is the main thing, is I wanted to go through and share, because many people don't realize that these options exist, or they think, hey, look, if I use this certified body or this certifying body, this is it's black and white. There's only these ones ways, but really no. There's a lot of flexibility. Functional safety, these standards are now giving us the flexibility to offer these services and to allow other people to do the work. And I think it's fantastic. As long as you have those people that are the competencies there to perform the work. So I do appreciate it. Let me look and see if there's some questions here and see if I can help answer anything. The first one I have here is a guy had to jump off. No problem. Can you have access to the webinar and a copy of the slides? Absolutely. I'll also be doing this webinar probably, what is it? Probably like in 5 hours or so. I think we have to do the same webinar again. And but yeah, I will have one of these sessions recorded. I'll throw it up on our YouTube channel, and the presentation slides will also be delivered shortly after the second session is done. So I will supply that. So thank you for that question. is there a guideline for the amount of time or amount of units for proven in use? Yeah, Stephen, absolutely. What we can do, let me see, you said, let's say we have 3 years of experience and sell 60, 70 units per year. Is that enough for proven use? What we can do, Stephen, is I'll respond back to you and actually everyone else. I'll take all these questions down and I'll actually give you the chart so then you have something like a reference, like a cheat sheet. So I'll go ahead and provide that to you. That's no problem at all. And actually, and to your question there, I'll just email you directly and let you know where you stand as far as proven in use and if you meet it or not. So that's no problem at all. Absolutely, I can do that for you. Any other questions? Got another question here. The question I have is if we have a product in development and they, what does it say? Oh, so they want to know, can we do, it looks like more of an a la carte system where, hey, can we start the process, but then can we finish up later? Yeah. So what you can do is, even with the certification process, you don't have to do it all at once. If you're not ready, you're not ready. So you can start the initial gap analysis. You can go through that process here. Let me put up a chart with the flow so that we can, oops, sorry about that. Let me go back into presentation mode here. Swap slides, sorry about that. Let me get to, yeah, something like this. Yeah, so what you can do is, yeah, we can go ahead and perform that gap analysis for you right away. And then you can figure out the gaps. You can sit back and say, okay, well, this looks great. I'll fix these when I can, but at least I know that I'm on the right track. Or some people even get that architecture concept review done where they look at the FMEA, the FMEDA, and that's the only portion they do so that they know, hey, my design is correct. And then they move on maybe like 5-6 months later and they finish their certification. So yeah, you can absolutely do it piecemeal. So that is also no problem at all. And that's actually not uncommon. All right, next question is, what is the typical time period for certification? And they said for an IC chip. Well, well, let me help you answer your question. Really, for me, I would tell you, it depends. And I know, and that's not trying to get an out in your question, but really it depends on that manufacturer's process. If they have a great quality management system and they're used to SIL certification, you're looking at maybe 2 or 3 months, right? If you're not really familiar and you're going to have some gaps and this might be your first time, it could be 4 to 6 months. And really what it depends on is, when we do certification jobs, we dedicate at least 2 engineers for every single project, that they're only working on your project during that specific timeline. So we have guys that are 100% dedicated to your services or your certification. Therefore, when questions are asked from that customer, we can quickly get back to you. We can answer the questions. And the longest hurdle in the tent, so to speak, is the manufacturer. What level of support are they willing to give to get this certification through? And also, how much work did that manufacturer want to perform on their own, right? So if you're saying, hey, look, we just need this product finished, exida help us, we'll have that proposal, we'll give you the price, we'll go through it all for you, and we'll help by providing guidelines and templates and books to get you through it the quickest period. That's your 2 to 3 month type of idea. But yeah, it takes a lot longer. It only depends on that manufacturer. And so if you want a quick analysis, we can do something initially and kind of gauge what we think for your specific company, how long it'll take. So if you want, we can do that as well. That's a good question. So what is the difference between the system cert and a component cert? I would say, if I understand you correctly, so like a component cert can be just something, it could even be a simple device, like almost as small as even like a relay, or it could be maybe just a sensor, or it could just be like a device, right? So if you look in the standard, they classify things as devices, as elements, and then you have systems as well. When I think of a system, I think of, hey, I want to take this valve and I want to take this actuator, I want to put them together, right? I want this thing to be integrated. What is the certification for that system? Or you can say, I have this logic solver, I have the sensor and this final element. I want a certification on those 3 things together, right? And so I kind of see that as a system cert. And that's possible. That's something we can do as well for you. Usually an end user is the one that will pick different things out, and we'll do a cert on that. Or they can say, hey, look, here are different options that I want to purchase. What is a, we'll call it a type certification, where as long as I use these variances of products, or even, hey, I have this one product with these different models, as long as I stick within these models, can I have a certification for this family? And that's also possible. I didn't even speak about that, but yeah, so you can even group products into a family, a type certificate, and get multiple things done in one experience. So good question. What do you recommend to someone that has no experience and has a product in the field for 4 years? What I would recommend, Bob, is I'd like to first, if you want, you can send me some more information on, well, I need to know how many units you've sold, and then we'd look at the operating hours for all of those different units. If you hit proven in use, what I recommend, can I get on my slide here, is for you, I would tell you to go option 2 if we can get it to proven in use. We would help you along the way. We'd provide the templates, we'd provide workshops, and that way you don't have to become an expert. There's no reason for you if this is not something that you're interested in. However, you can let us be the experts. We'll do the work for you. We'll guide you through the process, and we'll go that route. So that was what I would say is let's go for option 2. If cost becomes an issue and you still need our help, then of course I'd say, hey, look, we're going to have to go option 3, right, where there's no changes. However, I always start with option 2 if that's possible. That's usually where most people get the most flexibility. It's the better cost for you to go through certification. But yeah, send me an email. We can talk more on that. Yeah, and I agree with you, Paul. The proven in use is definitely. Oh, you would like to use proven use data too? Yeah, absolutely. I think that is the best route as well. Let's see here. A lot of questions. What about components that manufacturers don't get certified because the SIL application is a pretty small part of their business? Well, it's one of those things. How bad you need it. And here's another thing before we get too far, not off topic, but when people get things certified, we have requests every day for products that we will not certify. If we don't feel it's part of that safety function, we reject the job and we will not certify it. So if it's a small part and it really doesn't play a part in that safety function that they're developing, or it doesn't have a safety function, sorry. If it doesn't have a safety function, it can't put itself in a safe manner, right? Because that definition of functional safety was, oh boy, that's at the beginning, isn't it? Yeah. So the goal is, look, it needs to put it in a safe manner. If it can't do that, we will not certify that product. And we get requests all the time. So if it's a small part of their business, and really the biggest thing is, a lot of people look at their sales. Well, is it going to increase my sales? And then what is the risk as well? Is this something that could really have a huge impact if it doesn't work correctly? And then that's when we justify the cost, and we'll go into those things to figure out that cost benefit type of thing. What's the value to that cost? So if you want, Bob, go ahead, send me an email as to what you're thinking of, and then I can provide some more information on it as well. How is it done when a software revision happens on an already certified device? Great question, Michelle. What happens is if you do have a product that's already certified and you do go through the option where it's with changes, at least with our company, right? I can't speak for I know a lot of certifying bodies, no matter what change you make, you have to go back to them and you have to have them perform another analysis. But for us, what we say is if you make your software change, one, if it's safety critical, you at least tell us you made the change. We don't have to do anything with it, as long as you perform those procedures that were in place to get you to that certification part where you're allowed to make changes. Because what I mean is when you make a safety change, you then need to perform what we call an impact analysis, which is basically you look at that change and then you say, okay, with this new change, you go back into your safety life cycle where it's fit, and you make sure that the new change, didn't affect something else in your system. And you do these checks. You maybe have to perform a test on your software and make sure it works correctly. You verify it, you document it. And then when we come back and recertify that product or do the surveillance audit, you show us these changes that you made. We'll check off on them, and then you're good to go. And so you don't have to worry about coming back to us as long as you have a certification with changes. You just have to make sure you document it on your end so that when we come in to look at it, we can just give you a thumbs up. What if you already have a functional safety certification in automotive? That'll be helpful. And I'm trying to remember what your first question was. Oh, for the IC. So what happens is, what we would do is, it would be less expensive for you to get another product certified to 61508 if you go through 26262, because when you get a product certified to 26262 or the automotive, we already know that you've met a lot of the quality management systems. So that systematic capability side, a lot of those things are already checked off. So as long as that certification was done with the same certifying body, cost savings can happen. If you use a different certifying body, it gets a little trickier because that certifying body doesn't know what the other certifying body did. However, you'd be a much easier spot, and that certification process will go a whole lot faster because you already know that you successfully completed a certification process, and your timeline will be reduced to complete your job. So it says, if I'm designing a safety module, do all the components I use, example semiconductors, on that module need to be safety certified? Whatever you're going to say, this is a safety system, you need to provide justification that what you've used in that system are that will meet the standards, right? So whether you do it by prior use, proven in use, so no, I mean, there are companies that want to get semiconductors SIL certified because they're becoming extremely smart. It's incredible what some of these products can do now that are on the market. But if you're designing the safety module, basically what I recommend, Tom, is, I mean, I wouldn't even mind if you want to just send me what you're thinking of. I can at least provide some kind of guidance for you. No charge or anything like that, but at least I can share, hey, this is what I would probably do, or these are the things I probably would look into getting certified if they're not certified, and kind of give you a quick estimate of, hey, this is the approach I would take if you are trying to get maybe the safety module to be used in a safety critical system or in a SIF. But it's hard to say at a very top level if all the components need to be. I would just say, look, really, certification is not even needed, right? However, it just helps you overcome all the obstacles when that end user needs to use that product. Or if you are the end user, it now helps you justify, hey, I can actually use this with confidence, right? So really the biggest thing is you need to provide that justification, and the liability gets put on the manufacturer if they don't get something certified in that sense, right? So the liability is greatly increased when a product's not certified and they use it in the safety system, if that makes sense. So I hope that answered your question. Awesome questions. That's all I had for now. Do know real quick, all these questions I'll go ahead and put into a Word document. I'll send them to everybody. There'll be more questions in the afternoon session, but I'll capture those as well. If you're looking for any kind of training, just real quick, look, this is what we have coming up in different parts of the world. Whether you're looking for 61511 training, if you're looking for product training, if you're looking for even manufacturer with 61508 training, and of course, if you're not already joined, jump on these social media things. If you're tech savvy, we're always giving away free white papers, updating with books. We're always giving new information about different things that we've experienced or gone through. So it's really useful to be a part of that. Oh, and I already answered that question. Okay, so that was it. Hey, guys, I really appreciate your time. Thank you so much. I hope you found this webinar useful. Feel free to ask me all the questions you want. You got my email address right there in front of you. Thank you so much. I take care, and we'll speak with you soon. Take care for now.